Okay, let's see. We have an easy one. 1-bit and 2-bit characters. We have two special characters. The first character can be represented by a 1-bit 0. The second character can be represented by 2 bits, either 1, 0, or 1, 1. Given an arbitrary array of bits that ends with 0, return true if the last character must be a 1-bit character. The last character must be a 1-bit character. So 1, 0, 0. So can you make this into 2-bit? I think this is no, right? Because you can't, has to be true. True if the last character must be 1. Oh yeah, that's it. The last one has to be a singleton, because if this was 2, then this has to be a 1. Like you can't have, there's no 0, 0. Okay. So I mean, I only have to look at the last 2 characters. Probably not. I think I probably have to look at more than that. So this one, false. You can have this be 1, 0, 1, 1. Yeah. Huh. There's some cases that are not in the examples here, but probably are less obvious than just looking at the last 2. So obviously if the last one is a 1, then it has to be a 2-bit character. So that logic should probably be first. If bits at -1 equals 1, then return false. Return true if the last character must be a 1-bit. So return false because the last character is definitely not a 1-bit character. So then the second case is going to be if the last character is 0, and you'd have to look at the second to last character. The second to last character is 0, then it's definitely true. The second to last character is a 1. Is there still a chance that, yeah, if it's like a 1, 1, 0 here, if the second to last character is a 1, then there's still a possibility that the last character is a 0. Interesting. I don't know if this is really that easy. So the question is, can you group these into a double and then have some correct assignment for the stuff before that? So if if this is a 0, then it's definitely going to be true. If the second to last character is a 0, return true. I guess the bits could be just a single length. If it's a single length, then it definitely is going to be true. I think that I need to check that before I do this because it'd go out of bounds otherwise. If length of bits is equal to 1, return true. Okay, so now it's going to go down to the second to last character is a 1, the last character is a 0. The second to last character is a 1, the last character is a 0. if it was a 3-length array, the first value is 1, like 110, I think that returns true. Because then you can't make this thing. I think that means the third to last has to be, if the third to last is a 1, then return true. If the third to last is a 0, at that point I think it can go either way. I don't think there's anything forcing that after that. So if the length, if the second to last is a 0, okay. So it means we're at last two characters are 1, 0 at this point. So yeah, it's 1, 0 at this point. So if it's a 1 here, it's 0 here. If it's a 0 here, then that's fine. So then it'd be a singleton and a double. If it's a 1 here, then that's not fine. And if it's 2 characters, then it's fine. So it's only bad if it's 3 characters and this is a 1. If there's 3 characters and this is a 0, or if there's more than 3 characters, then it should be, I'd return false, I think. If the length of bits is equal to 3 and the start of that is now 1, this is the last case where it has to be a singleton, 110. Okay. That's the extent of my logic that I can fully analyze. Now I think I'll just do some random stuff. Let's say 0, 1, 1, 0. Let's go with all zeros. Let's go with 3. Let's go with 1, 0, 1, 0. And let's go with 1, 1, 1, 0. I think anything ending with a 1 should be working correctly. Oh boy. 0, 1, 1, 0. So this thing has to be a singleton. And then this has to be a double, right? Yeah, this can't be a double, because then this thing doesn't combine. Oh boy. Is it a 1-bit character? Wonder if I can do this recursively, maybe. So if it's a single bit, then obviously it has to be singleton. If the last one is a 1, then obviously it can't be a singleton. Wonder if I can just pop. see if it's return 0. Yeah, I wonder if I can just somehow pop right here. Pop the last thing from the array and then do recursion. Alright, so let me think here. 1 0 1 0 0 1 1 0. So is the last thing a singleton? Could be either singleton or double. So that means that if it's not singleton, then it needs to go with this. Needs to go with this, and also it needs to have 0 1 be possible that this is. What does it mean here? 0 1. Let's somehow group that, right? Well, I can't group it actually. Oh my god. 0 1. So if this was a 1, okay, this is a singleton, then this has to be some valid set of things. Or if I make a subarray or sub function for isValid. IsValid. If this is a 0, then the only way this works would be if this is a singleton. So therefore, this has to be the start of the next one. But if this was a 1 here, let's say it was like that. Yeah, so if it's a 1, then it has to go with the next, it has to combine with the next one. If it's a 0, then it has to be a singleton. Okay, I think I actually might be just doing it wrong. I think I might just need to parse it. Because if the first character is 0, then it's a 1 character thing. First character is a 1, then it's a 2 character thing, and then, yeah, okay. I think I need to parse it. Let's see now. I think I go index n equals length of bits. I think it's probably while true. Or while index is less than n minus 1. Not sure about this. If the bits of this index is equal to 0, then I want to increment. Else it's going to be a 1, so I want to increment twice. So it's a 1, so I skip over to this thing. It's a 1, I skip over to this thing. this is a 1, I skip over to this thing. So it's either gonna end up being at n minus 1 or at n. Yeah, and if it ends up being at n minus 1, then that means it can start with a 0, which means it can be a singleton. So I think its return index is equal to n minus 1. Otherwise it's equal to n, and that means it has to skip over the last one. So the last one is a double. Huh. Okay. I guess Pythonically this is like that. Huh. Alright. Not particularly fast, I guess. Okay. I think maybe I need to just do the trivial cases first. So if it ends in a 1, then it needs to return false. And then otherwise, if it ends in a 0, then that's the ambiguous case. I guess if it ends in a 0 preceded by another 0, then I can possibly do that case as well. Ends in a 0 preceded by another 0. Do I need to check? So that's this point ends in a 0. Let's see how fast this is. If this gets rid of most of the slow cases. Okay. Ends in a 0. So that's the ambiguous case. And then even if I look at the previous one, it could be a 0, and then I have to look at the previous one to that still. Yeah, okay. That's the only kind of, that's one of the more straightforward cases. Ends in a 1, has to be a double. Okay. This is closer to hard or medium. But anyways, the logic here is going to be kind of trivial case. If bits array ends with 1, must be of a double. So return false immediately. And then otherwise there's lots of possibilities that can be more correctly determined by looking, that can be determined by looking at the starting bit and parsing from there. If first bit is 0, continue to next. If first bit is 1, must be, no, well, this is, must be singleton, continue to next index. Must be part of double, skip 2 indices. Either arrive at index n minus 1 or n with this method. If arrive at index n minus 1, then n minus 1 is singleton. Return true. If arrive at index n, then skipped n minus 1. So last must be double. Turn false. Alright, time complexity is going to be O of n, as it requires a single pass through of bits in array. And space complexity, this can be O of 1, since no extra space is needed. Alright, cool beans.